go about getting the outputs for this using the QA, QB, and enable. Starts with the letter K and ends with the word maps. K maps. All right? So, because I've already done this, to save us some time, let's see how this is going to be displayed. C3, C2, C1, and C0. Can anybody figure those out before without doing a K-map? Can you figure out what the simplified would be for any of those without doing a K-map? Sure you can. Look at C3. C3, all you have are these two. What are true about these two that nothing else is true about? A, B, not, right? You see the A, B, not? Is there any place on here where you have A, B, not? Hello?
No.
So for C3, we've got QA, QB not. There's your simplified for the C3. For C2, we have, what, QA not? How do I get QA not out of C2? See it?
Yeah.
What about C1? QA not QB? And what about C0? QA. All right? So that is what's displayed on the output. So where do those come from? They come from the flip-flops. I'll draw you a picture in just a second that will help you imagine or help you to understand and to see where these are coming from. One other thing. DA and DB are inputs. They're inputs. Remember? D is an input. So the QA and the QB and the enable have to loop around and come into the DA and the DB. So we need to do the same thing for that. We actually need to do a K-map, and we need to simplify what's going to go into these. I've already done that. DA is going to be equal to this. DA is equal to QA not, QB enable, or QA enable not, or QA QB not. Or you could call this A not B C, or A C not, or A B not, if you wanted to change those. What is DB going to be equal to? DB is easy. QB enable not, or QB not enable. And you can use an XOR for that too if you wanted to. AC not or A not C, here's an XOR gate. All right, so here is the circuit. I do not expect you to draw this, but I do want to show you how this has been set up. Here's our two flip-flops. Here's our flip-flop A, that's the LSB, and here's our second flip-flop, that's the MSB. LSB, MSB. This is A, this is B. So the input DA is right here, and the input DB is right here. The output QA is here, the output QB is here. That would make this QA not, and that would make this QB not, right? Follow me. If this is flip-flop A, this is QA. If this is flip-flop B, this is QB. QA, QA not, QB, QB not. the inputs into dA and dB, we just wrote the Boolean expression for those over here. So dA and dB come around here, QB and QB naught come around here, and they become the inputs to dA and dB by just using some AND gates and OR gates. And these are actually labeled QA naught, enable, QB. By the way, this PowerPoint is on Haiku if you need to see it. QA naught, QB, enable. QA naught, QB, enable. QA, enable not, just like I wrote on the board. QA, QB naught. Take this Boolean expression, throw it into DA, and there you go. Here you've got QB and enable not, QB not and enable, into some ands and ors, goes into DB, and there you go. So the QA and the QB loop themselves back around and become the inputs. By the way, we have enable over here, so we have the enable here, and we have enable not right here. So we can get those over there. So here's our one switch to do the whole thing. When is this going to cycle through? Every time enable is high. I go to enable is high, and it'll start cycling through. When I go low with the enable, everything stops. It holds on whatever number that we've done. So if I'm going to take this enable switch and just go switch it up, I see a number change, I turn it off, it's off. I turn it back on, it goes to the next number, and then I turn it off, and so forth and so forth. So I can use this enable switch in an on and off position to cycle through 4691, 4691, 4691. In fact, if I leave it on, if I just leave it on, it'll cycle through by itself. And we don't need to sit there and toggle it on and off. It'll actually do itself. It'll just go through if I wanted to. The outputs over here, here's our C3, C2, C1, C0. Here's QA, QA naught, QB, QB naught. And you can see that these are all going into a whatever kind of combination to get those lights to shine. That is a state machine. Okay? No. Question, David.
So when you're saying it's cycling through,
Yeah.
the clock control, how fast?
Yeah. Thank you for bringing that up. You'll notice that the clock inputs in the two flip-flops, I forgot to mention this, are both synchronized to the clock. This is a synchronous counter. All right? So it has to be synchronous. If it isn't synchronous, if it's asynchronous, nothing's going to work.
Yeah.
It has to be synchronous to get that signal to trigger each time. Yeah. And they just got it at 20 hertz. You can make it 50 or 100, however fast you want it to go. Okay? All right? So what we're going to do, I'm going to give you your assignment. Let me talk about the assignment and what you're going to do. I will tell you that there's two parts to this assignment. The first part of the assignment is almost just like this. I did the phone numbers 4691. You're going to do your own form, and nobody else can do 4691. Yeah, so if it is 4691, you got to use a different phone number. Okay? So part one of the assignment is that you're just going to redo this to reflect your own phone number. And then you're going to do it on there's three things in part one. The first thing in part one is you're going to redo the state tables, the truth table here, to reflect yours. Part two, you're going to do it on the second thing you're going to do in part one is you're going to do it on multi-sim. And then the third thing that you're going to do in part one is you're going to do it on the DLB. So you're actually going to take a little toggle switch, and it'll actually toggle through the last 4 digits of your phone number. Part two of the assignment is that you're going to do the entire 7 digits of your phone number with a dash in the middle. You're going to redo this. You're going to use 3 flip-flops, and you're going to go with your outputs into a 7-segment display, and you're going to be able to go through your phone number like this. Let me show you this. Well, it's even more fun than it was last year.
It was supposed to be really easy for me because I had 5.
Yeah, my number was
He's my TA. He's my TA.
he went across to where it's one of my family members to that you Martin B. C3 went across to the